What's up, everybody? Welcome back to yet another episode of Basic Chem 101 with Sitlebonani. My name is Sitlebonani, and today we are dealing with the mole concept. Not as niche, but moles of substances. Let's go.
This is for every child that wants to make it one day. Izimbo class and presence of mind is elsewhere. Swinga usuzani afna kuhle dlale. Already alisibani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
1 drop of water is equal to 2 times 10 to the power 2 molecules of H2O. Now that's a very big number, but when you're speaking of chemical reactions, what reacts is actually those molecules of water. So what we will be looking for in, mostly as chemists, what we'll be looking for in chemical reactions, we'll be looking for molecules or ions of substances in order for us to know what exactly is the amount needed in order for me not to waste my chemicals or reagents, or to use little and then I don't get my products. So understanding of how many molecules are there in your given substance is very important, and this is what we'll be dealing with today. So this is basically the beginning of calculations. In order for you to understand going forward calculations that we use in chemical reactions or in chemistry in general, you will need to understand moles or how to calculate moles. But that is actually basic chemistry, but we'll not be starting there for now. We'll be starting with molecular masses. So if you're talking about molecular masses, you're talking about a sum of all atomic masses in a molecule. Remember, atomic masses in an element or new periodic table of elements. We have it today. New periodic table of elements. You have your element, and then you have your atomic number, and you have your atomic mass. So if you have a molecule, for an example, which is H2O, you're gonna add the atomic masses of hydrogen and oxygen to get the molecular mass of H2O, which would be 2 times molecular mass of hydrogen will be 1, and then plus molecular mass of oxygen, which is 16. This is 1, this is 16. So this will be in atomic mass units. So this is 2. So the molecular mass for oxygen will be 18.0 atomic mass units. So that is what you first need to know in today's lesson to calculate the atomic mass of, the molecular mass of your molecules. That is there is also, if you can see, H2O is a molecule, but iron sulfate is not a molecule. But if we are talking of another compound that is not a molecule, for an example, this one, This one is an ionic compound. This is a molecular compound, if you go back to what we spoke about. So for this one, they will look for what is called a formula mass, which is basically the same thing as your molecular mass. But now, this is not a molecule, so they will ask for a formula mass. They can ask for a formula mass even for this one, because it is still a formula. So for this one, you will have 2 times atomic mass of iron, and then you're going to have 3 times atomic mass of sulfur. Then you have 3 times 4 times atomic mass of oxygen. So you are adding all this. Then after you have added them, you'd find that your final answer would be 399.9 atomic mass units. So that is how you would calculate your molecular masses and your formula masses. Now let's move on to calculating moles. Now, if 1 drop of water is 2 times 10 to the power 2 molecules of H2O, as the number of drops grows, or the volume grows of water, it means the number of molecules in water also increase. So if I am looking for a number of molecules for my reaction or my experiment, it's going to be very difficult for me to individually calculate those molecules in water, those H2O molecules in water. And even if you have devices, it's going to take a very long time for you to calculate those molecules individually. So what chemists did was to adopt the concept of a mole. They would write mole as this. So they would adopt a concept of a mole. Now, a mole, actually, in a mole they speak about carbon 12, carbon with atomic number 12. And then they speak about carbon being 12 grams. So in a mole, they talk about a mole of any substance. 1 mole of any substance consists of the same number of molecules or atoms of carbon carbon 12 in 12 grams of carbon. So that is a mole, and the definition of it would be there. So the number of carbon atoms in 12 grams of carbon 12 is equal to 6.02 times 10 to the power 23 molecules or atoms or ions. So everything that you'll be talking about will be equal to, or will be related to this number. And this number is also known as the Avogadro's number, which is denoted as N. So 1 mole of any substance, 1 mole X, will be equal to the same number of atoms of carbon 12 in 12 grams. So if carbon atoms in 12 grams of carbon is this number, which means every mole of any compound is equal to 6.02 times 10 to the power 23 molecules or atoms or ions, depending on the formula units or what is needed in that equation. Also, there is a concept of a molar mass. If we are talking about moles, we'll be talking also about a molar mass, and a molar mass would be equal to your atomic mass, but now it will be in grams per mole. So remember, atomic mass was in atomic mass units, or the molecular mass was in atomic mass units, or your formula mass was in atomic mass units. But a molar mass now is almost the same concept. You would calculate it the same as your formula masses, and instead of writing atomic mass units, you would write grams per mole. Now that you know a molar mass, and now that you know a mole, now that you know formula mass and molecular mass, they can ask you to calculate the mass of one chlorine atom, for an example. So if you have one chlorine atom, what is the mass? Remember, we know that 1 mole of any substance is equal to 6.02 times 10 to the power 23 atoms. Now, we also know that the molar mass of chlorine is equal to 35.5 gram per mole. So if there's a concept of using conversion factors, so if I say this is 35.5 grams in 1 mole, this thing is gram per mole is the same as this one. So if 1 mole is this much atoms, I can invert this saying 1 mole is equal to 6.02 times 10 to the power 23 atoms. So this and this. So 1 chlorine atom would be 35 divided by 6.02 times 10 to the power 23, which could give us 5.9 times 10 to the power negative 23 grams per 1 chlorine atom. So that is how you would calculate the mass of 1 chlorine atom. You can also calculate the number of atoms or molecules or ions or formula units from a given mass. Now that we know these things that we know. An example, they would say calculate the number of atoms, let's say lithium, then they give us a mass of lithium which would be 8.21 grams of lithium. Now, how would you calculate the number of lithium ions from here, knowing lithium atoms from here, knowing what we know? Now, we can convert this to your number of moles first, which is 8.21 grams times 1 mole of lithium is how many grams of lithium? 6.94 grams of lithium. This is your molar mass. Then from here, once you get your number of moles, you know that in 1 mole you have 6.02 times 10 to the power 23 atoms in 1 mole. So as from here you would get your number of lithium ions, of lithium atoms in 8.21 grams of lithium. They can also ask you to calculate the number of formula units. Let's say you'll be given this sodium, your polyatomic ions, the sodium chloride. They will ask you to calculate the number of formula units. Then they will give you a mass of this compound, which would be, let's say, 3.31 grams. So we do the same thing even here. Now this one would be 3.31 grams. So we'll have to convert this to moles. So 1 mole of this would be equal to the molar mass of this. You would add these atomic masses or molar masses of each individual atom. Then you would get 122.44 grams. Then 6.02 times 10 formula units in 1 mole. Then you get your answer. Then from wherever you are, you can calculate and get your answers. And then you practice more. Let's just do 1 more and then we stop for the day. They can give you chromium sulfate and then they say it has a mass 14.3 grams. So if this is chromium sulfate, there's 2 things that they can ask you from here. They can ask you for the number of formula units, which is this compound, the previous example that we did, or they can ask you for the number of ions. They can ask you for the number of chromium 3+ ions. They can ask you to calculate the number of ions from here, but we can follow the same procedure from here, and then we can say this is 14.3 grams. You change this to number of moles. The molar mass of this whole thing would be 392.21 grams. Then this is 1 mole of this compound. Now if this is 1 mole of this compound, it means 1 mole of this compound is equal to 2 moles of chromium. So if this is 1 mole, so this is 2 moles of chromium, because we are looking for chromium. It's 1 mole of chromium sulfate. Then you have moles of chromium sulfate, Then from there you can calculate the number of chromium ions by multiplying by 6.02 times 10 to the power 23 ions. So you would get your answer. This would be your chromium 3+ ion. So that is how you would calculate your number of chromium ions, in that if they were looking for the number of formula units, it would not get this step, because now we are talking about one compound. But now we have to break it down, because we are talking about an ion which is in that compound. As you practice, I believe that you will get what I am trying to say. Once they ask about atoms, molecules, or ions, or formula units, just know that you will have to use the Avogadro's number. But if they just ask for the number of moles and the number of moles from the mass, or they ask for the mass from the number of moles, chances are you might not use the Avogadro's number. But once there is atom, molecule, or ion, we'll be talking of your Avogadro's number. Then that's it for the day. Thank you very much for watching. My name is Sihle Bonan, and this has been Basic Chem 101 with Sihle Bonan. See you next time.